Okay, so let's take a step back now and take a loop at loops in general. So just to make sure we drill in the point, we'll see that loops are generally used always to iterate through some sort of list or to traverse an array. It's an extremely common structure. You use it all the time, and there's probably not many algorithms that don't use some sort of loop.
That's true.
You're always going to be using loops, so no loops. So if you're lost at this point, or lost at the end of this video, maybe just kind of keep going through it again a few more times. Look at some examples. Even Wikipedia is not a bad source for looking at loops.
I mean, to see how common loops are in algorithms and even basic stuff is when you get up and you walk over to get something, the process of you walking is a loop. Because for each step until you get to your destination, you're looping through a process in your brain which is foot forward, or falling forward and catching yourself, which is what the act of walking really is. So let's take a look at a kindergarten example. Let's do, we want to eat cookies. So let's say that we want to eat exactly 5 cookies. So what loop structure would we use to do this?
Let's find out.
Okay. We're going to use the while loop. So what Wabbit the Frog here is going to do is he's going to eat 5 cookies. He's going to eat 1 cookie until he's eaten 5 cookies. So he has 1, 2, 3, 4, 5 cookies. He's met the end condition of this loop. The loop is now complete.
So the while loop works just like it sounds. So we want to eat 5 cookies. We, in the beginning, haven't eaten any.
Right.
So while we haven't eaten as many as we want to, we eat one.
Exactly. Yeah.
So I mean, it's very, very natural language.
So that was a great example, Brian, but there is another loop structure that we can use to eat exactly 5 cookies. And it's a lot less lines.
That's true.
And what is that loop?
It's the for loop.
The for loop.
So this is kind of similar, but in this case, whereas before we defined how many cookies eaten and how many cookies we want to eat before we even entered in the loop, this can all be self-contained in a for statement. So this acts the same way as the last loop, but we can just say for. We start with initially there's no cookies eaten. We want to eat up to less than 5 cookies and increment by 1. We're going to eat 1 cookie at a time. So for every one of these iterations, we eat a cookie, eat a cookie, eat a cookie, until the number of cookies we've eaten is 5. And then we break out of the loop.
Oh, and now he's getting a little full. So
Right.
we may have to go to the next day. Oh, good, look at this. The next night.
This frog's going to blow up with all these examples.
Yeah, but he's getting a good meal. A good hearty meal. So the next time that, or the next night.
Do frogs eat cookies? Should have been a jar of flies, maybe.
It should have been a jar of flies.
Anyway.
What the hell? Man, we suck.
But who has a jar of flies sitting around? I mean, that would just be weird.
Well, Alice in Chains had a jar of flies. Remember their album, Jar of Flies?
No, but they would.
They had an album called Jar of Flies.
We're so intelligent, you just don't understand what it means to be a jar of flies.
That does sound like a David Bowie record, though.
Yeah, right.
So the next night...
A jar of flies in space, man.
Space. With a shiny spacesuit. So the next night, Wabbit the Frog wants to eat at least 1 cookie until he's full.
So not some predefined full, but just some arbitrary, abstract full.
Yeah, whatever my fullness is right now, I'm going to eat at least 1 until I don't want to eat anymore. So the loop structure that we would use, Brian, is the do while.
Right.
Because as we explained before, in a do while structure, the loop iterates at least 1 time until the end condition is met. So in the do while, Wabbit the Frog, as happy as he is, because he had a whole night to digest the cookies from the night before, he's going to eat 1 cookie, and then he's going to check. Do I want to eat more cookies? So he calls the am I full function. So he's going to have another cookie. Then he makes the decision, yeah, 2 cookies was enough. So now eat more cookies is not true. So the loop exits.
So now let's look at another example. So even later that night, you want to eat the rest of the cookies in the jar. So you don't really have a lot of the controls that the other loops have. You don't have the conditions of until I'm full or up until 5 cookies. You just want to eat everything in the jar.
You've made the decision. This is it. I'm getting fat
I'm
tonight.
committed.
Yeah.
Like, that cookie jar is mine.
There's nothing you can do about it.
Get in my belly. So we would use the for each loop.
How do you know that? Oh, because the slide says so.
So in this case, and this is in a lot of languages, pretty much most languages have this, and it's a very convenient way to just move through everything on a list. You basically just say, for each cookie in a jar, eat a cookie. So it just grabs the entire set of cookies, and it just goes every single one of them until there's none left.
And then, oh, now he's really full because that was a lot of cookies.